Okay, I'm using somebody else's iPad today, so I apologize for the quality of this video, but I want to get it up before I'm gone this week. We are going to talk about lesson 4-6, which is solving equations with 2 steps. So you guys have become pretty comfortable with solving one-step equations, and now you are going to be solving 2-step equations. And for our learning target, we are going to basically write, okay, sorry about that. So the learning target is going to be to solve 2-step equations using inverse operations. Now a reminder for you guys, and this vocabulary that I have on here, you can see I put vocabulary, reminder, because we've already learned these, but I want to keep emphasizing these in our learning so that you guys can remember this vocabulary, because you'll need to know. We get really used to calling it opposite because that's what's easy in our head to remember, but we need to know the mathematical term. So inverse operation, the definition of that, you could look it up from section 4.3 if you wanted, but the definition is operations that undo each other. Go ahead and write that in. Another way to say it is opposite operations. And then again, the word isolate is a vocabulary word that we've already learned. Same thing, section 4.3. And the definition of that is to cause to be alone. I use that word a lot. When we isolate a variable, we're getting a variable alone. And in this case, we are now going to be isolating 2 times. So we're going to be isolating the variable and what it's attached to, and then we will also isolate the variable again to get it by itself. So we'll kind of go through that. So if you look down on your notes here, the first example I have is 5n minus 18. The first step, and again, if you look down here, I wrote them for you, is to isolate the variable and everything attached to it. So 5n is what we want to get alone. The thing that's in the way here is negative 18, and remember that's the same as minus 18. So if this is subtraction that's happening, the inverse operation, the opposite operation is addition. So if I add 18, and I want to just continue to emphasize that you have to show your work the same way that I do. All right, I'm going to bring down, I think I'll change colors here for you so you guys can see. I'm going to bring down my 5n. That isn't dark enough. Negative 18 and positive 18, those cancel each other out. Bring down my equal sign. And then I have a negative and a positive, which means I'm going to subtract and keep the larger sign. So I know my answer will be negative, and I end up with negative 15. And again, this color is not dark enough. Okay, so now, this was step 1. And I got 5n to be alone. This part here is a little bit easier for me to see. 5n equals negative 15. We've done a lot of problems like this. We know how to do this. This would be step 2. 5 multiplied by n, so the inverse operation would be to divide, divide, divide. These 5's cancel each other out. I'm left with n equals, a bad thing happens to a good guy is a bad thing. N equals negative 3. It's important that you remember these 2 steps. We isolate the variable and everything attached to it, which would be the 5n, and then we isolate the variable, which is n. So here I've put this on the board and I've told you a lot, but I thought it would be helpful for you to just write it down in your notes. What undoes multiplication? We know that division undoes multiplication, and multiplication undoes division. Subtraction undoes addition, and addition undoes subtraction. You can always, when you're looking at these problems, look and see what's happening and then go back to this little key here that'll show you what you need. Okay, so now to continue on to notes, I've got two examples here. The first one is negative 8y minus 28 equals negative 36. Remember, the first step is to get the variable and what's attached to it alone. So that would be negative 8y needs to be alone. But I have this negative 28 in the way. So negative, the opposite, would be positive. So I'm going to add 28, add 28. It's important that you put a plus sign here on these so that you know what you're doing. I've seen in your work, a lot of you are just doing this. You have to actually put the plus there so you know what's happening. Okay. These cancel each other out. Bring down my negative 8y equals, I have a negative and a positive, which means I'm going to subtract and keep the larger, and I'm left with negative 8. What's happening here is multiplication, so I'm going to do the opposite, the inverse operation, which is divide. If I divide the left by negative 8, I have to divide the right. These cancel each other out. I'm left with y equals, a bad thing happens to a bad guy is a good thing. I'm left with positive 1. Next example. Now this is going to mix things up a little bit. I have a division and addition here. It's the exact same rules though. My first step, I have to isolate the variable and everything attached to it. The variable and everything attached to it is x plus 3. That's what needs to get alone. What's in the way is plus 11. The opposite of plus 11 would be minus 11. Whatever I do to the left, I must do to the right. I'm going to bring down x over 3. These cancel each other out. Bring down my equal sign. And I'm left with 5, positive 5. Now, this is where I know a lot of you get stuck. You see these divisions and you freak out. But all you have to do is remember that the opposite of division is multiplication, which means I'm just going to multiply this by 3, and I'm going to multiply this by 3. The reason I always have you put this over 1 is for you to see that they cancel each other out. You don't have to do that. You can just put a 3 if that makes it easier for you. But you also have to remember that you multiplied the left by 3, so you must multiply the right by 3. So what I'm left with is x equals 5 times 3, which is 15. The more we practice these, the better you're going to get with them. And if you turn to the next page here, we've got just a couple more examples that I'll walk through the next two with you, and then I'll hit pause and do the other ones, and you can do the other ones as well. This next one is very similar to the one we had. We want to get x over 5 by itself. That's what needs to be isolated. Plus 35 is what needs to go away. So we need to do the opposite, which is subtract 35. It's kind of sloppy. Subtract 35. Bring down my x over 5. These cancel each other out. Bring down my equal sign. 75 minus 35 ends up to be 40. Now I am looking here at division. I still need to isolate x. It's not alone yet. It's being divided by 5. The opposite of dividing is multiplication. So I'm going to multiply both sides, cross these out. I'm left with x equals 200. Now I can go back and plug that in. Is 200 divided by 5 plus 35 equal to 75? And when you figure that all out, you should see that your answer is yes. Okay, this next example, 5p, my first step is to get 5p alone. The thing that's in the way is negative 2. The opposite of negative would be positive, so the way to get back to 0, I'm going to add 2 to both sides. Bring down my 5p. These cancel each other out. Bring down my equal sign. 18 plus 2 is 20. Now, this is 5 multiplied by p. My goal is to get p isolated all alone. I know that it's being multiplied, so the inverse operation is division. Divide by 5 on the left, divide by 5 on the right. These cancel each other out. I'm left with p equals positive 4. So I'm hoping that you're getting the hang of this. What I'd like you to do now is hit pause and do the last two. Don't forget what happens when you have a negative, a minus a negative. And I will also do the same, hit pause and do these, and then we will, and then I'll show you the answers. Okay, so the answer for the first one is 12. You'll see here that the first thing that I did was rewrite this as 7n plus 16. That's because when a negative and a negative touch each other, you have a minus and negative here, it changes into positive. So I've rewritten this as 7n plus 16. Okay, so I'm not sure where I left off there, but once you change this minus a negative to a positive 16, then you have to subtract 16 from both sides. You end up with 7n equals 84. 7n, remember, that means 7 multiplied by n. The inverse operation would be division. You end up with an answer of 12. The next one, the answer was 18, and it's very similar to the last ones that we've done. Now, if you look at this last word problem, we'll walk through this. It says that renting boats on a lake costs $22 per hour plus a flat fee of $10 for insurance. You have $98. Write and solve an equation to find the number of hours you can rent a boat. Now, I walked through this before I started recording to kind of show you my thought process and how I set this up. And I also underlined write and solve an equation because it's important that you remember that you have to write and solve an equation. If it says that, then you'll be docked points if you don't do it. I know a lot of you can just figure this out on your own without an equation, but the point is for you to get practice doing this. So I know that the insurance plus $22 per hour is equal to how much I have to spend, because I'm trying to figure out how much I can buy with my $98. So the total paid is $98. $22 per hour. This per hour, this is what I don't know. My per hour is going to be my variable of X, because I am trying to figure out how many hours I can rent. 22 is going to be multiplied by that, so it'll be 22X. And then the insurance that I'm going to pay is 10 bucks. So it'll be 10 plus 22X equals $98. Now this looks very similar to the type of problems that we have been solving. So I've got a positive 10 here, and so I'm going to subtract 10 to get rid of that because I want to isolate 22x. These cancel each other out. I'm left with 22x equals $88. This is multiplication, 22 times x. The opposite would be division. These cancel each other out, and I'm left with x equals 4. So I can rent the boat for 4 hours. For sum it up, 2 things that you need to know, okay? First one is you now have to, so I have to isolate 2 times now. Before, you only had to worry about isolating once. Now you have to isolate at least 2 times, and it'll get even better. At some point, you'll even have to isolate more than once. And if you think about Dragon Box in the game that we played, you eventually, it gets harder and harder and harder, and you have to isolate more. And then the second sum it up is I'm going to solve by using inverse operations. So I'm just going to write inverse operations here, because you guys have to remember and be confident in what undoes each other. Okay, so multiplication undoes division, division undoes multiplication, addition undoes subtraction, subtraction undoes addition. Okay, so this is solving 2-step equations. It's very similar to 1 step, just adding 1 more step into the process. I hope that this has been successful. You can watch this at home if you need to, or on YouTube with the sub. Thank you. I will see you guys soon.